All right, so what if I told you that just about everything you've ever been taught about electricity is, well, wrong? What if there's this limitless source of clean, free energy all around us, and we just haven't figured out how to see it yet? Today, we're diving deep into a really fascinating and, yeah, pretty controversial 1993 paper by T.E. Bearden that claims it holds the final secret of free energy. And this paper, it does not pull any punches. It kicks right off with this incredibly bold claim you see here, that our whole understanding of electromagnetic energy is built on a house of cards. Bearden's argument is that before we can ever hope to unlock a new source of power, we first have to tear down the old, flawed science. So, before we get to the big secret, the paper basically puts on a prosecutor's hat. It lays out this detailed case against the science we all learn in school, classical electromagnetics, or CEM. The central claim? The entire structure is built on a foundation that's totally shaky. And the problems, according to this paper, are deep. It's not just one little thing. We're told modern physics is still haunted by this 19th century idea of a material ether, something that was disproven way back in 1887. It argues that we don't even have solid definitions for basic concepts like charge or potential. And get this, the equations we use today are supposedly just a simplified, kind of dumbed-down version of what James Clerk Maxwell originally came up with. The paper's conclusion is just staggering. The entire field needs to be thrown out and started over from scratch. Okay, so if the old rulebook is garbage, what's the new one? Well, the paper proposes a pretty radical new way of looking at things. And it starts by completely redefining the most fundamental ideas we have about energy. Let's start with the biggest, most basic question of them all. The paper argues that the answer we all memorized in school isn't just a little bit off, it's completely backward. The standard textbook definition is that energy is the capacity to do work. But this paper says, nope. It argues that's totally wrong. It claims work isn't energy. Work is what happens when energy is used up or dissipated. It's the friction, the grinding of the gears. Instead, Bearden redefines energy as any kind of ordering that's forced upon the vacuum. So think of the vacuum not as empty space, but as this chaotic ocean of virtual particles just bubbling in and out of existence. Energy, in this new view, is when you get those particles to stop being chaotic and start flowing in a structured, orderly way. And this new way of thinking about energy? Well, it has this huge knock-on effect. It completely flips our understanding of what scientists call potential. And this is where it gets really mind-bending. Because if energy is just an ordered flow of vacuum particles, and potential is also defined as an ordered flow of vacuum particles, then they're the exact same thing. According to this paper, the potential in a battery isn't just some static number. It's an active, hidden river of incredible energy, constantly flowing from the vacuum through the battery's poles and back out again. So this brings us to the moment we've been building up to. If there's this giant, hidden river of energy flowing all around us, how in the world do we actually tap into it? Bearden makes this absolutely shocking claim that all of us are energy source killers. He argues that the way we build our circuits is fundamentally self-destructive. When we hook something up to a battery, half the energy goes to power our device, and the other half is wasted destroying the very potential in the battery that's giving us the energy. And he uses this brilliant analogy to make his point. Imagine a water wheel. The river is the vacuum energy. The sluice gate that lets the water through is your battery. Now, what kind of engineer would design a system where the turning of the water wheel is also powering a pulley that slowly closes the gate, shutting off its own water supply? It's insane, right? Yet, the paper claims that's exactly what every single standard electrical circuit does. So the fix, according to this paper, is to break that stupid, self-destructive loop. The solution is a two-cycle process, and it hinges on a brand new critical idea. You have to completely separate the act of collecting the energy from the act of using it. Okay, so here's how it works. Step 1, collection. You connect your source, like a battery, to a special collector. But here's the trick. You only connect it for a tiny, tiny fraction of a second. It's just long enough for that river of potential to instantly fill up the collector. But it's so fast that the actual electrons don't even have time to start moving. You've essentially just scooped up a shovelful of energy from the river without draining the source one bit. Then, and this is the magic trick, in step 2, you instantly switch that collector, which is now full of energy, away from the battery. You connect it to a totally separate, closed circuit that has your light bulb in it. The collector becomes its own little temporary battery, spending the energy it gathered to do the work. The original battery,
It's completely untouched, out of the loop. You just keep repeating this two-step process, shuttling energy over to the load again and again without ever draining the main source.
Now, this sounds, well, it sounds revolutionary, and it begs the obvious question. If it's this simple, why isn't every single thing we own built this way? The paper claims the secret isn't in the circuit design itself. It's in the materials you use to build it. So, yeah, why can't you just go down to the hardware store, grab some copper wire, and build this thing? The answer, according to the paper, comes down to just one thing: speed. 1.5 times 10 to the negative 19th seconds. That's the electron relaxation time in copper. It's the gap between when you apply potential and when the electrons actually start to move. That number is so vanishingly small, it's basically meaningless. It's instant. There is no physical switch on planet Earth that can operate fast enough to open and close in that tiny, tiny window of time. In a normal wire, collecting the energy and spending it happen at the exact same time. So the proposed solution is a special material, what the paper calls a degenerate semiconductor. Here's an easy way to think about it. If copper wire is a perfectly smooth, frictionless water slide where electrons just go instantly, this special material is like a water slide filled with thick mud. It's still a conductor, yeah, but it's been doped with specific impurities to deliberately slow those electrons way, way down. The goal is to stretch that relaxation time from practically zero to something manageable, like 1 millisecond. That's more than enough time for a switch to do its job. Now, let's just imagine for a second. If this theory is correct, and if a material like this could actually be created, the paper claims the implications would, well, they would transform our entire world. We are talking about a future that is just purely utopian. An end to pollution, no more nuclear waste, the power to lift entire nations out of poverty with cheap, abundant energy. The paper even takes it a step further. It suggests that by understanding the deep electromagnetic nature of the human body, these very same principles could lead to cures for diseases we currently think are incurable, like cancer and AIDS. The paper concludes on this almost philosophical note. It argues this incredible, limitless source of energy has been here for us all along, hidden in plain sight, obscured only by our own failure to understand the true physics of the universe. And that leaves us with one last, really provocative thought from this paper. It claims our circuits are designed to be suicidal, wasting half their energy just to kill their own source. So the question it leaves us with is this. Is that just a simple mistake, a result of our own scientific blindness? Or, as the author seems to hint, is it a consequence of a system that needs us to keep paying for fuel? That's the question this paper leaves us all to think about.